research work since a couple of years. And it's been a while that I'm in a current state where I could present the findings that I got from the research work after that which we have conducted since 2020. So moving ahead with today's presentation, these are the contents. Like we are going to start with the introduction, what exactly the entire domain is all about. Then what was the motivation and the problem context, followed by the research gaps and the problem statement, the objectives that we have laid down after going through an intensive literature survey, then the methodology and the experimental setup, followed by the proposed algorithm or the framework that we have finally drafted, and the results and discussions, our contributions, conclusions, feature works, references, and appendix. So before getting started with anything, as usual, as all slides have, probably like the introduction, what exactly the entire problem is all about. So, or what exactly the scenario is, what is the domain, and how exactly it got started. Now, if I just come to the slide, you see towards towards the right hand side of the screen, you see a vending machine over there, right? It's a vending machine from the Coke, from the famous brand Coca-Cola, right? And why exactly do we have a vending machine in a research presentation, right? Let me tell you that this vending machine is not just a simple vending machine. Back in the year 1980s or back in the year 1982, this was the point where researchers or where the students of Carnegie Mellon University created the entire paradigm shift by developing one of the most futuristic device in the computing history. What they did is they connected this vending machine, a normal vending machine, which was obviously manual in those mostly mechanical in those days, and a little bit of electronics, mechanical and electronics, basic mechanical and electronic device, and connected this entire device to a network. Basically, what they were very lazy enough just to come from third floor to the ground floor and just to understand the Coke is whether chilled or whether hot. First point. Second point, whether the vending machine is going to have the current stock or not. Like how many number of cans are there and what is the current status, what is the temperature of the can that is stored in this machine. So they were so lazy enough that from the third floor to ground floor, they didn't want to come sitting from the lab. They wanted to understand what is the current scenario of the vending machine. So what they did is they connected some sensors to this vending machine and just connected this vending machine to the network so that sitting from the third floor itself, they could understand the scenario. So this was what exactly the students and the researchers did in CMU. But knowingly or unknowingly, they created one of the most futuristic technologies for the upcoming years. That's the IoT, Internet of Things. Basically connecting every device with the internet. So this was the start. And from then till now, the rest is history, because here you see this is what exactly IoT is all about today. Starting from smart cities to industries, as well as smart homes, from agriculture sector to smart health, everywhere we see that devices are connected with each other, just sending informations, data, such that informed decisions can be made. Now, based on these principles, we thought, let us take this as the primary domain and let's see what exactly that can be done in this particular domain. Now, we all know that since these devices were getting connected with each other, probably in the year 2018, they didn't even knew that there is going to be a plethora of devices that are going to get connected in an immense way. In this chart by a famous analytic portal, that's IoT Analytics, you can see that what they're forecasting is that this was old data in the year 2018. What they forecasted is by the year 2025, we are going to have around 21.5 billion devices that are going to be connected from IoT domains, and from non-IoT domains, which was dominant in the year 2015, is going to get recessive in the year 2025. Right? This was back in the year 2018 that was predicted. But later on, as you can see, this is the current scenario by the year 2025, quarter 4. A stands for the actuals, F stands for the forecasted values. where as per the actuals, in the year 2024, we had 18.6 billion devices connected and forecasted around 55 billion devices connected around 2035 with an average year-on-year growth of 11.8% per year, per annum. So you see, there are pretty much devices, or there are very large scale of devices that are going to get connected to each other just to share the informations, or just to share the data, right? And we know as soon as the number of devices get increased, right, with the increasing number of devices, we are definitely going to have increasing number of data. Now, what to do with this data? Should we just keep the data in the data warehouses, or should we just keep the data in the hard disk, in the servers, and do nothing? Right? No, we have to do something with the data, right? That was the point where we understood, no, there is a huge amount of data that is getting generated, and we can utilize this data for our insights for better prospect. Now, going through the literatures, we came to know like what are the different type of domain where this analytical operations can be done. Now, from the analytical point of view, this data can be utilized to perform 7 different kind of analytics, like descriptive, diagnostic, predictive, prescriptive, real-time, edge analytics, and cognitive analytics. Now, in order to understand better, what we did is we went through different situations, like in different domains, in which analytical platform, what kind of research was exactly done. So from those domains, we are presenting few literature papers which can help us to give a quick idea what exactly scholars have done and what is the existing research work that was already being done before conducting our own research, right? From the literature reviews, although we we went through multiple papers, but since in this presentation we cannot have all of them, so we are presenting few of them. To be very specific, 7 of them were presented out of the multiple papers that we have studied. Out of them, the first paper, it was a survey paper where they surveyed about all the existing technologies that was being used to perform the analysis. To be very specific, the analytics, how the process was conducted, and it was mostly about descriptive and predictive, using the ML task like simple classification or simple regression kind of thing, right? And no new algorithm as such were proposed. And here they didn't discuss about existing works, where they studied about real-time data streams, where the latencies were covered, as well as the memory usage, and all those points were covered. Now, coming to the next paper, as you can see here also, it was also a survey paper. But yes, in the survey paper, we got to know that yes, 5G, because back then 5G was pretty much new and people started using 5G enabled devices to connect IoT devices. Yes, there is also something called BFG, B5G, that's beyond 5G. That was also discussed in this particular paper. And yes, again, no new algorithm were proposed, or no real-time data streams were used to perform those analysis. Now, coming to the next paper, right? In this paper, what we have done is, what we have gone through is, yes, what we have gone through is, we went through the papers where what we understood is they used IoT to connect smart cities. And while connecting, or while enabling the option of smart cities in modern cities, what they discussed is, they discussed about a gap such as the online clustering algorithms or the real-time clustering algorithms are very much required to analyze this kind of data which are getting generated from the smart cities that are being connected via IoT devices. And also they have discussed how exactly clustering is very important from energy efficiency point of view, from load balancing point of view, as well as from getting the informed decisions from those data that are going to get generated from this devices. And here what we have understood is, here this was a different kind of paper which was discussing about diagnostics and and detective analytics, diagnostics and detective analytics by using digital twin technologies. Now, what they did is they deployed multiple sensors into multiple locations and also the digital twin of that, such that those sensors readings as well as those diagnostics can be done based on the readings that those sensors are going to provide. And moreover, what they have done is they have used some rule-based mechanisms like a black box kind of thing. The input comes in, it gets processed, and you get the output, right? And there is a standard format. There is no adaptive learning kind of approach, right? So that was the issue in this particular paper. And here next to this paper, again a clustering algorithm was used. Here also no real-time analytics was done. No unsupervised clustering models were used. It was mainly focused on network layer, where they were discussing about lifetime congestion and security. And if we come to the next paper, right, this was something which we thought to be very much interesting because they proposed an improved clustering algorithm. But as like going through it, we got surprised because again they discussed mostly about the batch processing or offline data, not online data or real-time data. The data was in a spreadsheet. From that spreadsheet or from that CSV file, it was directly provided to the model, and accordingly those analytical operations were done. This was something which was the most interesting, and very surprisingly, it's a paper from the year 2015 where they proposed, or where the title says real-time analysis of sensor data from Internet of Things by the means of clustering and event processing. Yes, it was pretty good enough, but the issue with this paper was that they used a window-based protocol, window-based mechanism. That means for a specific time limit, for a specific time frame, they were collecting the data, and after collecting the data, they were putting it in the clustering algorithm, and then they were getting the insight. No real-time data, no real streams of data, like just incoming data and just you put it in the cluster, not like that. So basically a time-based mechanism, not true real-time in true sense. So from this literature surveys, or from this brief summaries that I have presented from all those papers that we have studied, this was the gap that we identified: scalability issues, adaptability issues, latency issues, security, interpretability, integration, and evaluation. Right? From starting from scalability, like there were no such algorithm as of now which were pretty scalable enough to ingest or to go through large data sets. Adaptability being one of the most major issues, where those mechanisms which were already proposed were not intelligent enough to adapt to the current scenarios. Obviously, we know that clusterings are pretty slow in nature. They took a lot of time. That's why you see in the paper of real time from the IEEE, they used window-based mechanism so that they can keep the buffer time for the computation part, right? And yes, security issues, like there were no real-time anomaly detection or cybersecurity attack detection using those existing techniques, right? And based on these research gaps, this is the problem statement that we have defined to design and implement an efficient, scalable, and dynamic clustering technique capable of handling large structured as well as unstructured data with minimum time complexity and automatic cluster detection, enabling informed decision making, right? So this was the problem statement. Like we wanted an algorithm which was fast, scalable, and could also handle both structured and unstructured data, and could be intelligent enough to evolve with the upcoming data streams, such that from this data generated, we can go through some analytical process, and we can gain some information, and based on those information, we can come to the informed decision. And based on these problems, these were the objectives that were laid down. As in all, total 4 objectives were there, starting from the development of a clustering algorithm with less time complexity, and which can also determine the number of clusters more efficiently and accurately for large volumes of IoT data sets, to analyze the clusters using improved clustering algorithm and to find hidden patterns for both structured and unstructured IoT data set. Number 3, to form clusters of similar IoT devices and to reduce latency in IoT data transmission. And the last one, to detect vulnerability in clusters of similar IoT devices formed with the proposed clustering-based approach. Obviously, to tackle this particular objectives, we had a definite methodology, and based on this methodology and the experimental setup, we have tried our best to cover up the objectives that we have laid down from the research gap and from the problem statement that we have defined. So our methodology was divided into 6 phases, starting from the first phase, that was the phase 1. That was the survey of the existing techniques which already existed. Like you can see, there are 14, as in all total, 14 clustering algorithms which were studied. And from this study, we could find that among all the algorithms, right, there were few algorithms which performed pretty good with the large data, such as k-means, bisecting k-means, db scan, right? And yes, and the algorithm not to forget about, which became the baseline algorithm for our entire research work, that's none other than the algorithm Birch, right? The Birch algorithm was the algorithm which was pretty good enough and came out to be one of the best performing algorithms from clustering point of view, because the clusters were pretty segregated and pretty good enough. And yes, the total time consumption for this algorithm was also pretty low. And the phase 2, what we did is we created the entire cloud infrastructure, which comprised of connecting all those ESP32 devices with the DHT11 temperature sensor, where the data was collected and was sent to a localhost server. From the localhost server, we send the data to 2 parallel streams to ThingSpeak Cloud for visualization purpose, and to MongoDB. From MongoDB, we again send the data to Oracle Cloud Computing Instance, which was for the use for computational purpose. So basically what we did is we created a virtual machine in Oracle Cloud, which was used for computational purpose, where we deployed the entire algorithm that we have designed. This was the screenshots from the from the task manager of the machine that we created with the 256 GB of RAM and 32 cores with 2.6 gigahertz of base clock speed. And yes, since our methodology or our objectives also include unstructured data, so that's why we also created a heterogeneous data environment which comprised of Raspberry Pi with camera sensors, which were collecting data and were again sending the data to the local server. From there, it was getting propagated to the processing unit, where we had the real-time Birch deployed. From there, again, we were sending the data to the web interface. These are the snapshots with the geotag images of the devices that were deployed in various locations. This was back in the year 2022, 2023, quarter 1, 2 of 2023, where we have deployed various devices, edge computing devices, as in all total 6 ESP32 with DHT11 sensors in various locations. The longitude latitudes are already being displayed, and the MAC address and the IP address is also displayed. And just next to it, in the right hand side, you can see we have the Raspberry Pi devices with the camera sensors, and this is the MAC and the IP addresses of those devices. Since we wanted an amazing mechanism which could handle those streams in an efficient way, so what we did is we created parallel clusters, physical level clusters of 2 different components, one for collecting structured data and one for collecting unstructured data, specifically those images. Like towards the left hand side, we have the cluster of collection of the cluster of devices which were designed to collect the structured data, and towards the right hand side, we have the cluster of devices which were designed to collect the unstructured data. This is the entire geographical location of the devices that were deployed in various locations across, starting from ESP32 devices to Raspberry Pis in various locations, starting from the computer lab to server room to food court to outdoors, as well as to faculty houses. In the phase 4, obviously the data that got collected, we wanted to pre-process it to extract the features. Yes, yes, within the various locations, they can find out. Yes, yes, yes. You have in the place of. Yes. Even we are earlier thinking about to keep it in that bridge, Howrah Bridge. Yes, 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 yes. Later on, decided to keep it within the campus. Yes, yes. And in the next phase, what we did is we did some data pre-processing where the features were extracted from the data using VGG16 model. And since those were image data, so we had to extract the images. And yes, those experiments that we performed in an iterative way, where we performed multiple iterations of the experiment just to come to a conclusion that whether the experiment that we performed is or the algorithm that we proposed or the algorithm that we have finalized is a well-suited algorithm for the use or not. Again, we have decided what are the evaluation metrics that we are going to use, such as the execution time, memory usage, and the cluster quality indexes such as Silauti and Devious Baldwin index, which is also known as the DBI index. And then phase 5, that was covering the objective 4, like to understand what are the vulnerabilities that could be identified using the existing clustering technique. So what we did is we used a sequence of attacks that were launched in those devices that were deployed in various locations, starting from DDoS to deauthentication, evil twin, and ARP spoofing. Where initially what we did is we launched DDoS attack packets to those edge computing devices just to choke down those devices. And once they were out of service, we launched deauthentication attack immediately, such that these devices which were already connected in nature can get disconnected from the network. And right after they got disconnected, we launched an evil twin attack by spoofing the SSID name, such that those ASP32 devices as well as the Raspberry Pi devices could not understand what was the true SSID that were initially assigned to those devices, and they got connected with the fake SSID that we got generated. And once they got connected with the fake SSID, we were successfully able to launch ARP spoofing. That's the man in the middle attack, where we could easily get all the data. And the moment we got the data streaming, we could manipulate the packets, and we could change the values, intercept the values, and send fake values to the ultimate processing unit, such that all misleading values can be sent. So this was the pipeline of attacks that we performed, and we also tried our best to mitigate or to detect those attacks such that they can later be used for mitigation purpose. And the phase 5, also we have created the entire dashboard of the application that we have built. Typically it contain because of the projector resolution, I think it's not visible. Yes, so it's a flow chart.
In the screen, it is
Visible, yes. So it's a flowchart where you can see starting from like the typical applications that we have, from the login panel to dashboard, where we validate the user, and based on the validation we give the user the option to choose how exactly they want to analyze the data, right? And also we have kept all those algorithms like the k-means, dbscan, birch, and the modified real-time birch, such that they can perform a comparative analysis among all the algorithms that are found to be most suitable ones. Phase 6, last but not the least phase, where we have used the entire technique with a benchmark data set, and also we have simulated the entire environment just to cross-validate whether the proposed technique that we are going to use for our upcoming scenarios are quite competitive enough or not from scalability point of view, and as well as from generalization point of view, where we have also used this entire technique for non-IoT data streams as well. And we have also used some baseline streaming clustering algorithms such as CluStream, Clustry, and DBStream. And we have also checked how exactly the real-time birch was performing good enough. Primarily, we have selected 3 benchmarking datasets: RT-IoT 2022, Air IoT. RT-IoT 2022 is from an Indian university. Air IoT is from Triple IT Hyderabad. CIC IoT, IDAD is not to be introduced. It's one of the most famous and one of the most prominent dataset from Canadian Institute. Specifically, a benchmark, very good benchmark dataset, which is used since many years, because every year they publish a new dataset which they generate from the simulated environments. Like, why birch? Why the algorithm birch has been chosen, right? Yes, as said, very good enough to tackle large data sets, which we already came to know. Before moving ahead with what exactly we did, before explaining the mathematical model, let me explain what exactly existing birch does. right? For data set X, we have to define a threshold T. And once the threshold T has been defined, it scans the data, right? Creates cluster features. And based on the cluster features, it decides whether the data has to be ingested into the cluster or it has to be excluded or not. This was a very brief summary. But if I had to explain in a much more detailed manner, which everybody could understand, that is based on the mathematical equations. So here I'm going to present my mathematical equations of the existing Birch algorithm. The first and foremost point is to compute the cluster feature. The moment the data comes in, what we're going to do is we're going to compute cluster feature, which is going to have an LS and SS. N stands for the number of data points, LS stands for the linear sum, SS stands for the squared sum. Here you see in the bottom side, we have the equations for linear sum. It is nothing but the linear equation, linear summation of all the data points that are coming. For example, the moment we have 5 as the input data point, so right after 5 we have 6. The linear sum is going to be 5 plus 6, as simple as that. Square sum, 5 square plus 6 square, and the summation of it. And centroid, linear sum by n, as simple as that. The value that we're going to get from the linear sum divided by n is going to give us the centroid. Radius, square root of SS by n, and LS by n whole square. And yes, last part, what we do is we have this condition based on which we check the data point X is subtracted from the centroid, and if the value that comes out is less than the threshold, we ingest it into the cluster or we exclude it and we put a new cluster to it. But this is where the game changes with Birch. Let me tell you how exactly the game changes with Birch is because here Birch, what it does, since I said it's one of the most intelligent algorithm we came to know from the literature survey, what it does is it performs this check right after calculation of LS and SS and obviously the mu, right? Once it calculates it, then only it decides whether this data that is going to come, right, is suitable to get ingested into the cluster or not. Once that is found to be suitable, that is just the level 1 of suitability check. Unlike other clustering algorithms, which is just going to use the centroid, and based on the centroid, it is going to get ingested. The data is going to get ingested into the clustering algorithm. It is going to do a pass one check. After completion of the pass one check, it's going to calculate the radius. This is the final check. If it passes the radius, right? How exactly it passes the radius? After calculation of the radius, it checks with the threshold that we are going to decide. If it is less than the threshold, then only it allows the data to be get ingested into the cluster, right? So this was what existing Birch used to do. Again, time consuming, pretty much time consuming. It looks very simple, but yes, as soon as data comes, it is time consuming. But yes, it could handle large amount of data sets, large amount of data, large volume of data, which even we checked and cross-validate from the experiments that we performed. So what exactly the modified real-time Birch is going to do from mathematical point of view? This is what the modified equation or the final equation of an algorithm looks like. As soon as the data comes, what we're going to do is we are going to divide the data into multiple threads. So we are taking help of multi-threading concepts. For example, the data set comes with n volume. It is going to divide it into by 10. That is the total number of threads that we have decided. In order to keep it simple, what we have done is we have shown like this data set is going to get divided into 2 threads, thread 1 and thread 2, which is again in union of x1 and x2, again which results to the x, the entire chunk or the entire volume of data. So basically those 2 separate chunks are going to get computed into 2 separate threads, 2 individual threads. So that means if we have 10 points, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, first 5 lot is going to get computed into thread 1. The last 5 lot is going to get computed into thread 2. So the moment it gets computed into thread 1 and thread 2 gets divided into thread, then here we perform the calculation of cluster features into the individual threads. And since we are performing the computation of cluster features into individual threads, again it is our responsibility to merge those data and to find the global cluster feature. So here you see towards the right hand side, we have the equation for calculating the global cluster feature, which is a component addition. Component addition, that means the number of data points from the first chunk plus the number of data points from the second chunk plus the linear sum from the second chunk and the linear sum from the first chunk, squared sum from the first chunk and squared sum from the second chunk. Right after this, we also calculate the global radius, and then we decide whether this particular data needs to be merged or this data need not to be merged and to be kept segregated. As in all total, in a comprehensive manner, this the equation looks like CF for a time t, that means t, this is the time t, right? What we are doing is we are calculating the cluster feature for, let's say if it is 10, we are calculating the cluster feature for 0. Let's say, just to keep it simple, right? Again, addition for every cluster features subjected to checking of R. If the R is from the initial survey, as said, right? What we did, these are the summary that we got. As we already said that Birch was performing pretty good. Yes, you can also have a question like K-means were also performing good enough from the execution time point of view. But why did we choose Birch? Because the clusters were pretty good and well segregated. There were no overlapping as such in Birch, in the case of Birch. As you can see, these were the results from the Birch, starting from 40,000 samples to 1 lakh samples. Streaming samples. Let me tell you, these are streaming samples, not just simple values in Excel sheets, right? And from iteration point of view, the algorithm, the modified Birch that we proposed, right, or the real-time Birch that we proposed was pretty strong enough and had a low execution time compared to the existing algorithms such as K-means, dbSCAN, and the existing Birch. This was for every iteration. Like we computed hundreds of iterations for each experiment that we conducted, and for every iterations, the average time was pretty low. Yeah, there were certain peaks. There were certain peaks for certain samples, and those peaks were due to the latency in the network. Okay, sir. I will definitely mention it. Note it, sir. In asterisks, I will mention that these peaks are for the network latencies. Okay, sir.
But optimized one is the green one.
No, optimized one is the blue one.
Blue ones.
Purple one.
Purple one.
Purple one. Yes, that is the that is our proposed algorithm.
Okay.
Yes. And this is the average execution time. Here you see, towards the right hand side, we have the round of values. Just to make it simple, total of 5 seconds of time it took for the real-time Birch to get executed, followed by 6 seconds, 13 and 7 seconds. Now you might be thinking it's very less, like from the execution point of view, just 1 second of difference. But no, this is where the actual games happen, right? This is where the magic happens, right? This is the results from the iterations for every clustering algorithms. Now for hundreds of iterations, you see, again, the total memory utilization by the modified Birch is very high, right? Around 630 to 650 MBs, right? But existing algorithm, the memory utilization was low. But let me tell you, for every iteration, they computed for every instance. That means for every iteration, they kept the memory utilized. That means after computation, they didn't make the memory free to use. For example, let's say hundreds of data points came, they performed the computations and kept the data points as it is in the memory. So the memory is being occupied. So again, if I had to run once again, I have to stop that program since there were no right? Because this was the algorithm which was using the same instance for the computation. Every time we need to stop the program and again rerun it, right, manually.
X-axis, this is what's the range?
From 1 to 100.
1 to
Yes, sir.
just 1, 10, 20, 50. Let's keep it like this.
Okay, sir. Not so much.
It will put visible because 1, 4, 7, this is not good.
Okay, sir. Noted, sir. Okay.
Interval,
This
you can
is equal interval, right?
Yes, sir.
So,
Yes, sir.
so इसका scale change. As per the scale, this is
Equal
like half of
interval.
10.
Okay.
It
It will be easier for to understand.
Just left side,
Mhm.
those ways that you did, na?
Yes, sir. For the y-axis, we will be doing the same for x-axis as well.
Instead of 3, you keep.
Okay. 10, 10, 10. At a cap of 10. Okay. So we'll just visibility will be better. Yes, agreed, sir. We'll do it. And if we compare the algorithm with the state of the art techniques, that means the existing clustering techniques, like here you see, what we did, as already said, we took some benchmark data sets, real-time IoT 2022, Air IoT, CIC, the Canadian Institute of Cybersecurity dataset 2024, just to check whether our algorithm is performing well enough with those benchmark data sets or not. So these were the results. These results are pretty big enough. So I'm just going to come right one after the another. But before discussing about the results, let me tell you, batch of 50 doesn't mean 50 samples. Batch of 50 means that 50 data points at one go. Since it was a real-time streaming technique, so we streamed 50 data points at a single stream. Again, there was next iteration where we streamed 100 data points at one go, 200 data points at one go. Similarly, we did the same thing with ClusteringTree and DBstream, ClusteringTree, and the modified real-time batch. To get a comprehensive understanding of all these results, what exactly the performance is all about, this is the summary of the table that I'm presenting as of in this slide. In this slide, you can see that the average score of modified batch, the real-time batch, from similarity point of view is 0.63, which basically says that the range should be between -1 to 1, and the devious boundary index, which always says that the range is between 0 to infinity, but more the less value that we get, more best it is. So you see that out of all this algorithms that we have tested, or the state-of-the-art techniques using the benchmark data sets, right? Similarity is used for cohesiveness, and DBI is used for checking the compactness of the clusters, how well compact those clusters are. So we see that the modified batch is performing good enough in comparison with the second best performing technique, that's the ClusterTree, because the DBI index is pretty good, that's 0.55, and the similarity technique score, or the similarity score, mean score, is also close to the ClusterTree, that's 0.57. Overall, the performance of the real-time batch was found to be good and satisfactory. To proceed.
So here, left side, it should be 0 to 1.
Okay, sir.
Because
Upper bounds, yes.
Is around 0.9.
Yes, sir. Till 1.
Till
1.
Oh, yes, sir. Understood, yes, sir.
No, this is okay.
Upper bound, yes, like for the y-axis, we'll keep it till 1. Okay, sir. And coming to the experimental evaluation on structured and unstructured data, because this was one of our objectives. For the structured data, we were able to identify the anomalies very easily, where you can see in the clusters, we are getting a temperature of 253 degrees Celsius, which are not at all real, because we cannot have 253 degrees Celsius of temperature in real world. So those were those anomalies were being detected very easily. And towards the left hand side, we have the elbow technique curve, where which shows that as a total 4 clusters got generated, which is matching with the exact number of clusters that got generated from the real-time batch. Oh, for the projectors.
Screen it is visible.
Still, I will make it large from next time.
Black.
The ticks are not visible.
Scales also not visible.
Scales are not visible. Yes, sir. I will make it large.
I think better be either I think you should make it black.
Black, black.
So then it can be visible.
Yes, sir. Sure,
I
sir.
think this is not.
It is not. It is not. It's a gray color. That's
So
what.
Black is.
Black. I will keep it black. Yes, sure, sure, sure. Okay, sir.
At least scale should be visible.
Sure, sure, sure. Okay, sir. I will just do that.
This line, I think, in the main graph line, make it little thick.
Thick. Okay, 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 sir. Okay, sir.
It will be clearly visible.
Okay, okay, sir. I will make it bold and I will make it black for
Because of the
visibility.
square boundary is visible.
Yes, sir. Yes, sir.
So similarly, your x-axis, y-axis
Oh, yes, sir.
is not visible.
Okay, okay.
So keep it always any graph, keep it in that this is a box that should be in B.
Okay. Okay, 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 sir. Noted, sir. And these are the extracted features from the images that were collected from the Raspberry Pi and the camera sensor. Like there are a lot of features, and based on his heat map and based on the importance of the features, what we did is we used our clustering technique again to cluster the data. But here there is something which was not good, which was not so good enough, because here for the images, what we got is we got some overlappings of clusters, because here there was a scope of improvement for our clustering technique. That means our clustering technique was performing very good enough for structured data. For unstructured data, we got some overlappings and we decided, so we have to optimize this for the further usability. But yes, yes, sir.
And I think this is a scale should be outside, not inside.
So this is the scale, sir.
Actually, boundary, if you remove the boundary.
Boundary, yes, yes, sir. It will be okay.
More,
Yes.
Deterministic.
Yes, sir. Yes, I will do it. I will do it, sir.
Actually, he is putting the result from the experiment directly here. You can do the modification. You can keep it.
Yes, sir. Yes, sir. Okay. Okay.
I
Okay.
think to make this whole graph, this is in a boundary.
Yes, sir. Yes, sir.
But,
Without boundary, I will generate.
This is the x-axis and y-axis.
Yes, sir.
You can make it left and right. It can be also a boundary.
Okay. Okay. Okay, sir.
So this is the left side that you can keep on the right side.
Yes, sir. Yes, sir.
Without rescaling.
Okay. 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 Okay.
This that can be also a box.
Okay.
So
Okay.
both
Understood,
outside
sir.
box.
Yes, sir.
Okay, then it can be more clear.
Yes, sir. Okay. I will just do one thing, that for the x-axis and y-axis itself, I will make them boundary and keep them black and
This is
black and bold.
And this is the left side and bottom. That should be including with scale.
Yes, sir.
But when you want to keep it out, right side and top,
Yes, sir.
without, that should be without.
Okay. Okay. Okay, sir. Okay, sir.
And
No, no.
mostly when you refer to that, your literature, when you present thesis,
Yes, sir.
your figure number is important.
Okay. Okay. Okay.
Yeah,
No, figure number is figure number, which part of this.
No, here, sir, you no need to write figure. Step by step we are discussing. You don't need to write figure, just a caption also.
No, but I'm saying that when you will be presenting in the thesis.
Now, this is
This-
That's it. Figure 1. This is
Figure
figure
one,
2.
figure
Figure
two.
2.1.
Yes, yes,
If
yes.
I read
We
it,
did that.
and then I will refer to the figure one.
Yes, sir.
And like this.
But here you no need to write figure.
Okay.
There is a clear caption on this.
Okay. Okay. Okay, sir. Okay. Also, the projector was a little bit, yes, the color contrast of the projector is also.
Because our external members can see it clearly because in the screen it is.
Okay.
Okay. Okay. So yes, there were a few overlappings in the data, and if you move ahead, based on the Silhouette scores, the Silhouette scores were pretty good enough, 0.87 and 0.81. But the time taken for the unstructured data images were around 30 seconds, because there was an in-between process, that is the process of feature extraction from the existing pre-trained model, that's VGG16. And the memory utilization was low for structured data. For unstructured data, it was high.
Score, if it moves towards 1, then it is considered as.
Considered as
Okay, and it is getting 0.87, it is good.
And based on the experimental evaluation of structured and unstructured IoT data, so we're coming to the next point of discussion. That's the detection of the vulnerabilities from those data packets that were being captured using Scapy. It's a Python library which is used for capturing the packets. It is similar to the Wireshark, which is also used for packet capturing technique. So here, this was the initial number of or the initial number of values that were extracted, which contain a lot of features. But from there, we have chosen a limited number of features, starting from the length to the packet length to delta time and the packet entropy, port number, acknowledgement number, window size, and everything. Based on the correlation heat map. That means those values which were highly correlated were only kept in these values. And from that, this is the conclusion, this is the interpreting graph, where based on the number of packets, right, based on the number of packets, this left hand side that you see is a normal packet flow that is coming up. And as soon as we start sending DDoS attack packets, here this particular ticks, as you can see, the number of packet size suddenly got spiked to around 10,000, 1 lakh, right? As well as for the deauthentication frames, the right hand side graph that shows a normal data frame where this is absolutely without any anomaly, and the left hand side shows without any anomaly, and the right hand side that you see is with the anomaly where there are sudden spikes, because we were trying to deauthenticate the device from the SSID. And based on the packets captured, what we did is we tried to perform a clustering, which we are going to present in the next slide. And right after the clustering, based on the labels that got generated, we also used that particular values into a supervised classification algorithm, such that it can classify those packets, those labeled data, like which are the malicious ones and which are the non-malicious one. And out of the comparative analysis, we found that XGBoost classifier was performing very good, because the accuracy, precision, recall, and F1 score were good enough. And this is the confusion matrix, where this also shows a promising result. And these are the the classification of the packets, attack packets and the non-attack packets. The right hand side that you see are the classification of the packets. And this is the dashboard that you see that we have designed, starting from the login panel to the gauges, as well as to the real-time streaming values. And this is basically the real-time graph that got generated from our dashboard, where you see that red color clusters are those values which were classified to be as attack-based packets. There were again no overlapping as such, and the green color clusters that you see are the values which were attack. The red colors were the attack one, and the green color one were the non-attack one. And coming to the last point of the entire research work, that was the application testing of this particular existing clustering technique, where what we have done is we have tested two scenarios. One is a testnet where we have used Grok's API. Again, we wanted it to test from context point of view, using some modern scenarios such as LLMs. So we used Grok APIs to get the data from the LLM, because using Grok APIs are now very much popular in today's computation world. Every developer nowadays, what they do is, if they want to make some chatbots or something like that, starting from the baseline developers, what they do is they prefer APIs, using APIs instead of training their own LLMs from the scratch. But the issue with those APIs are that those APIs, as a free of cost APIs, they have some limitations, such that you get a limited number of transactions that can be performed using those APIs, because you get limited number of tokens. So we wanted to optimize that process as well using clustering techniques. So what we did is we created an application which could generate question papers, can do also text to task converter like an agent, and PDF summarizing, grammar checking, and subject specific chatbot. Let's say for physics, for computer science, okay, for let's say material science, for basically subject specific, right? So we built these three components. So based on the prompts the user were giving, what we did is we classified the users and we labeled the users using our own clustering algorithm. Again, here we see that based on the number of prompts and the average responses, the token length, the concurrent users that we are going to get, based on all those parameters, we have classified our users into 4 major clusters, and these are the results with and without clustering. With clustering, the response time was around 27.4 seconds, and with clustering, it got reduced to 20.9 with an improvement of 23.6. And the major improvement came in question paper generation and in the prompt token length with an improvement of around 40.3 and 40.6%. And the second application that we have is the application where we built an application tracking system. Now, this is not something new, but what we did is we integrate ATS with AFS, which is a new part, like the application filtering system. Towards the topmost part that you see is the point where we generate data using GAN. Obviously, we had baseline data set of CVs that were collected from the students, and based using those CVs, we populated it to some extreme amount of size, absorbent amount of sample size of around 1 lakh, 1.5 lakh CVs, and we just took those data as a real-time streaming data to our hybrid framework, where initially it was trying to add labels to those data, and the moment it tried to add labels to the data, it took the data to perform adaptive learning using some supervised classification techniques, just to classify the CVs into few classes, like the class 1 CVs, like these are the best candidates, class 2 CVs, the second level best candidates, class 3, class 4 CVs, like that. And this were the results from the clusters, starting from 12,000 with a sample size of 12,500 rows to 25,500 rows, where we got 2 clusters at initial stage. Again, here also for 37,500 rows and 50,000 rows, we also had 2 clusters, and the black markings are the cluster centroids. And here also you see the moment the size increased, here we started getting 4 clusters for 87,500 rows and 1 lakh rows, sample rows. And again, based on those after performing the labels to use our classification not very good, I would say, because if it is around 8 or around 9, something like that, it is considered to be as very good. But for various classes, we have various values such as 0.63 for class 0, 0.65 for class 8, class 3. What is our contribution from this work? A framework for real-time IoT data, a framework for real-time anomaly and vulnerability detection, a framework which could be used both for structured and unstructured data, a framework for non-IoT streaming data as well. What is that framework?
One is related to for objectives.
Yes, all related to objectives. That is the real-time purge. Conclusion. Initially, from the literature survey, we needed like an algorithm which could be scalable enough to handle real-time streaming data. Our proposed solution was to develop an improved algorithm, that's the real-time purge which we have already shown. And lastly, we also did a validation and performance analysis among all the techniques that we have discussed. And the future work? Yes. Yes, sir.
The conclusion that you want to make,
yes, sir.
This is not, you should not guide you for need and motivation. This is not a conclusion.
Okay.
Okay, because this is a pure objective and your problem definition.
Okay, sir.
So that should not be a conclusion. Conclusion is those work that you have done. With that, based on this objective,
yes, sir.
that objective what you have done. So and what you got the result, that is the conclusion.
Okay, sir.
Objective wise.
Objective wise conclusion. Not
Okay.
any questions, any motivations, nothing else.
Okay, sir.
Objective one, what you have achieved.
Okay, okay, sir. Okay, sir.
Objective two, objective three, and objective four.
In general, when you want to write any kind of paper and any kind of thesis or any kind of proposals, so there is a abstract is a whole overall overview of this, and conclusion is just what you have done here.
Okay, sir.
Okay, so that result that you should focus here.
Okay, 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 sir. Noted, sir. Noted, sir. And coming to the future work, we are planning to use this technique or the framework from agriculture domain, where we want since we have a school of farming, school of smart agriculture. So yes, coming to the next, these are the references. These are my publication status. As you know, total 7 papers we have written, out of which
Is in the share.
yes.
Share.
Okay.
I'll follow it. Just the last.
We are also taken by.
Yes, yes, and we are thinking about that actually. That is completion will go for that.
Because I feel that work and some part can be better.
Yes.
I mean, not only 1, 2, 3 patent you can separate.
We applied for one copyright in the year 2024, but it is on hold, sir.
It
Hold
takes time.
takes a lot of time.
Project is our main goal.
Project that you are asking for fund.
Yes.
But this is your main point of concern. So that is your work, yeah.
Yes, sir.
So this is different than the proposal.
We'll try.
Eco is different.
No.
Okay, so I feel
Is it visible, sir?
Yes, go to the last slide.
I'm just starting. So again, I'm changing the screen. Yeah.
this
This
is
are
my
my
publication
publication
status.
status.
Like
As
as
you
you
know,
know,
total, we have produced 7 papers, out of which
one
one
got published in a journal.
Actually, 2 times.
Okay.
one got
published in a journal.
journal,
In a Scopus Index journal, and the first one that you see is which is fulfilling objective one. Got published in
ECS Foundation Conference. The second one got published in IEEE Conference.
The
The third one got published in Scopus Index Journal. The fourth one that is communicated to very reputed journal, which comprises our primary work, is journal paper. The fifth one is Leonard Francis book chapter, which is published and yet to be indexed in Scopus. The sixth one, which we recently presented like 10 days back, right before coming over here, is currently in production state. And the seventh paper is also being communicated to a journal. The fourth and the seventh paper we have communicated in SCI journal, and we are hoping for better results and better responses from the reviewer.
So we want to put this slide in Tejas is better.
Yes, yes,
Now
yes.
I think Tejas sir is the last program is for this.
The two communicated will not be required because we
No,
already
I'm asking last program.
Objective.
omitting.
Uh,
Objective method.
I think we will
Okay,
because if you give this one, then there are some questions with the objective and the publications. Okay, so
okay.
this portion I think
For only the discussion.
okay,
Okay.
presentation is okay, but in the thesis is not thesis.
Yeah.
Okay, sir. Okay, sir.
There are some questions.
Okay, sir.
So one, for example, objective one, you have three, four.
Actually, there are different boxes.
That's why we have
Yeah.
No, if I am a reviewer of this thesis,
He may
then one objective that can be made for paper.
Yes, sir.
But for other things,
Yes,
okay,
sir.
then I have a question. Okay, so
Okay.
that one is when I want to change this paper, I don't want to see about the objective one, objective one.
Okay, sir. Okay,
so
sir.
right last column.
We'll remove it.
Because sir is what to say, you will be wondering what about objective 2 and 3.
Only one single paper for the society.
Okay.
Yes, right.
Okay, and this is the entire timeline of the work that we have done, presented in the Gantt chart. Like what are the various work that were done with individual quarters of every year, and
But also you need this one.
okay.
Because timeline is your timeline.
Okay.
Either this is here or putting it. Either this is
Timeline.
And-
And because this is connected with the
Yes,
physics.
yes, right.
Yes, sir. And with that said, I'd like to thank you all for your patience hearing. This is not just a simple thank you slide, but the entire graphical abstract of what exactly the research work is all about. So thank you so much.
I have a quick question.
Now I already give all my things on the isolate.
Thank you very much,
Thank you,
Dean sir. So with this, we come to the end, and now I would like to request all the members, if you have any query, then please.
I have one question. When you calculate the radius, so that you can go to that slide.
Okay.
First radius, that square sum divided by only n.
Yes, sir.
Square sum divided by n and minus square linear sum divided by n square whole square. So always it will give you the positive values.
Yes, sir.
Square root of positive values.
Yes, sir.
So you can rethink about when if you are squaring sum, whether it is number of whole square or number of is it twice of number. It's not alone n, it should be 2n or n square. Just try to find out.
Okay, sir. We will definitely look at it.
Divided by, because divided by always you will get a positive value.
Yes, sir. Always we'll get a positive value or zero at worst case.
Zero is never get.
So zero will get, sir.
Then your n should be n square. Because a square, the summation of a square divided by only single n will never be, it is always a big number.
Okay, sir.
Single n. But if you say n square, then it will be close to n square. It's zero.
But sir, in our computation, there were instances where we also got zero as the radius, because if there are only one root of
you
x.
are taking the resource.
Yes.
So obviously zero radius. But zero will come. That we will check. That's what I'm saying.
Yes, sir.
So SS this part, the SS divided by n always will give you the, because suppose 4 square by how many 4 square by say 2 cluster. Always it will give you different. It will never be, this equation will never give you the zero. That condition to maintain, then try to find out where it will be zero, whether it is 2n or n square.
Okay.
Because it's the geometrical radius.
Yes, sir.
Geometrical
Geometrical radius, yes.
So try to.
I will definitely look
for
for
you.
you. Okay.
Number of points.
Yes.
Number of points, because always it will give you the because it's undercooked.
Yes, sir.
If it is a bigger, if by chance it's a reduce, then it will be your negative imaginary number. And so avoid imaginary number. Always it is boundary value will be R should be 0. And you can check it. You can conditional.
Yes, sir.
It should be 0, otherwise it can go to the negative.
I am in a meeting. Can I call you after?
So then, Hasin sir and Sajal sir.
One more question. Your clusters are fixed clusters. You determine to have the fixed clusters.
I couldn't understand.
When you configure
Number of clusters.
Cluster 1, there's a fixed point. Another cluster 2, fixed points.
Yes, sir.
So you are configuring.
No. It's not a fixed cluster. It will get evolved dynamically. Based on the number of data points that is coming, we are calculating beforehand like what will be the number of clusters. Based on the number of clusters, we are performing the clustering.
Okay. So this A includes that within the cluster.
And includes the number of data points that are going to get as
in a cluster. So number of data points in a cluster you have to write.
Okay.
In a single cluster.
Yes, sir. I will definitely write that.
Not in an entire number.
Yes, sir.
So is that
Yes, sir. Definitely, it's very important. Yes. We will definitely. Yes. Yes. Number of points in a cluster. Data points in a cluster.
Yes, not all clusters.
Yes, sir.
So then it is okay. And another thing is the result discussion. The memory resident. When you say the memory resident, then these type of things, if you have large amount of memory is very cheap, then result will be different.
Okay.
So you get a result differently because you are keeping the data of before iteration, first iteration data. You are keeping in that. If you need it compared to them, again you need not to go back to the algorithm, go back to load the data. Is not. So if you give the memory resident data, then it will be more faster. Speed will be your target will reduce the time.
Okay.
In this case, reduce the time. You will be getting less time.
Yes, sir. Okay.
One more.
Yes, sir.
One more. This result is for structured data, or you have experimented separately another graph for non-structured data.
Yes, we have. We don't have a graph, but we have a tabular format for unstructured data. This is for structured data.
So you have to mention.
Okay.
Yes, because it will change.
Yes, sir.
Structure, actually, nothing in the universe is non-structured.
Yes,
You have to transform into structure.
Yes, sir.
Transform into structure. So that transformation time you will take.
Yes, sir. Okay, sir.
All the questions.
Yes, sensible. Yes, sir.
This is a good call.
Yes, sir.
So this is a structure and non-structure also you can side by side one unstructured and
Side by side.
side by side another graph. Either the two concepts.
Yes.
You want to merge.
Okay, sir.
Okay. So actually I have a class. So I might believe that you can submit your thesis.
Thank you.
Thank you so much, sir.
Okay. All the best. And because I have taught you like
School.
child last year, so I know his potential. So get what you have done, but these points are very
definitely.
We will take care of process. Because for the unstructured data, we need to continue the work. We will try to improvise it. So that point we'll consider.
And especially in defining it is in a single.
Yes, sir.
Okay.
Number of data points in a single cluster.
Okay.
Thank you so much, sir.
I'll meet you after the class.
Sure.
Yes. Everyone can answer.
Yes, all the dignitaries, thank you for your presence. I am actually having a class right now. I am leaving now. Okay, thank you.
Okay, thank you, sir. Thank you very much, sir.
Oh,
Uh, Now, Hasinda and Sadal, sir.
Yes. Yeah. So I have seen his work, and he has fulfilled all the objectives, and I believe that it is also satisfactory in my opinion. So he can be allowed to go for thesis submission. Only concern is that whatever suggestion is given by the respective panel members, he should incorporate for submission of the thesis.
Yeah.
That's it.
Yeah, thank you very much, Sadal, sir. So we'll definitely go through the comments. Hasinda.
Yes, Divya. Yeah. Prabhat, I wanted to confirm certain things which will help you to you organize your thesis finally. First thing is, can you go to the objectives? Like you said, the last two chapters, and in the objective you mentioned about something evolving nature of your this thing, no?
Yes, sir.
So how will you relate that with your? I mean, whatever work you have done.
Sir, which number objective, sir?
Yeah, can you go to the problem statement?
Yeah,
Prabhat?
problem. Yes, sir.
We are not able to see it out there. I mean, probably the presentation mode is off anyway.
Okay, just a second, sir. I'm just presenting it. Just a second. Is it visible now, sir?
Not yet.
Is it visible now?
No, so just can you see that? I haven't been able to see there.
No, and now, right now it is visible.
Is it visible now, sir?
Wait. Oh, yeah, it's visible. Sorry. I was on a different frame. Yeah, it's visible now.
Okay. This is the problem statement.
Okay, fine. Where you have put the last two words there, I mean, if you go to the objectives, which objectives the last two words will be related with?
So I'm just coming to the
where you have used clustering to find out initial sort of classes, which are again fed to a clustering algorithm. Then you are evaluating those clustering algorithms, basically.
Yes, the objective, the last two works, sir. You're talking about the non-IoT applications.
No, I mean the ones that you presented, where you have used classification algorithm, but the initial classes you have made out of those clustering algorithms.
Okay. Yes. That is mapped with the objective number 4, primarily, where we are detecting the vulnerabilities in IoT devices. That is for analyzing the security weaknesses and attack imbalance. Basically, we're trying to label the malicious and non-malicious packets, and after that, we are feeding it into a classification algorithm such that as soon as the packet comes, it can be classified directly.
Yeah, so there I have a query. I mean, Prabhat, the thing is, you are saying you are basically, I mean, validating those clustering algorithms, right? But it seems there in those works, actually, you are validating those classification algorithms. Those clustering algorithms output is just a kind of ground truth sort of thing for the classification algorithm. Am I right?
Sir, I couldn't understand, sir. Could you please repeat so that yes.
In the last two works, what you have done actually, the clustering algorithms involvement in the whole process is to provide the
different classes basically, which
Yes,
are
yes, yes.
then after that you are using those class levels as the ground truth, and you are validating those classification algorithm, random forest and all if I remember. Then what you are doing, XGBoost and all. So you are validating those classification algorithms to, I mean, you are trying to find out how good those classification algorithms are to correctly
Map those
classify
classes. Yes, identify those classes.
classes which are basically the clusters, which
Yes,
I
yes,
mean, your algorithm has detected.
yes, yes, absolutely correct.
Yeah, so through that, I mean, will you be claiming it to be a kind of validation of your clustering, or that the classifications validation basically you are doing out there, right?
Yes, we can
You
claim that.
get my point, yeah.
Yes, 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 yes. As of
So,
now, yes.
what is the so instead of using the actual ground truth, where you generated some kind of a text, straight away you could have used a class level there. Instead of
Yes,
doing that, what you're doing, you are initially applying a clustering algorithm, then you are finding out the clusters which are fed as classes to the classification algorithm. So what is the justification of doing that instead of like straight away using the class levels? Like say, if it's an attack, you are generating an attack by using certain tool like as DOS attacks and all. So those
mhm.
levels could be straight away used there in the
Yes,
classification,
yes,
right? So
yes,
what is your justification of
yes,
using
sir,
that
yes.
clustering out there?
Like if we would have done that, then that would have been a rule-based technique. Like we know, like these are the malicious packets that we are sending, but the computer doesn't know. There are no certain specific rules or certain equations based on which we could just say if these packets are coming like this, then like this is a malicious packet based on some certain thresholds. Obviously, this can be done, but we wanted to go beyond rule-based techniques such that even if we don't know the pattern of the packets that are coming, right, we could cluster them, and based on the clusters we could at least give them labels like these are malicious packets or these are non-malicious packets, and these are, let's say, outliers or something like that.
Okay. So then what will be the role of the classification algorithm? Like in the real time, you are having certain packets there and you are applying that clustering to find out which are the malicious packets. Then what will
Yes.
be the role of the classifier then?
Yes. So the role of classifier is to cut down the computational time, because once the model got once we have the data set with the labels, we can then use it to train the model such that as soon as the data comes without effort, without a lot of complexities and a lot of computation, we can just put into the model, and the already trained model can just say classify whether it's a malicious or non-malicious packet.
Okay, you have to come up with a kind of very satisfactory answer of this question. Probably you got my query, no,
Yes, yes,
Prabhat?
yes, 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 yes.
That has to be addressed well there in the thesis. What I mean, with some kind of justification. Anyway, the another thing, have you done any kind of normalization on the data, because which is too sensitive?
Yes, sir. Yes, sir. Yes, sir. It's
What
mean
kind of
max,
normalization you
min
did?
max, min max.
Min max normalization.
Yes, yes,
Have
yes.
you checked with other kind of normalization technique like robust or
Yes,
jet score?
we like along with min max, we also use standard scaler. But overall, min max for our case, min max standard, min
Good.
max normalization was performing good to normalize the values.
Okay. And like computing the cluster feature, basically what you are doing in the modified bits, you are not relying on single value of cluster feature. I mean, cluster features. What you are doing, you are partitioning the data set, and for each partition, you are computing those values, and finally, you are merging them up using the formula that you have presented. Right? Am
Yes,
I
yes,
right?
yes, yes,
Okay.
absolutely correct, sir.
So there, you are always using two partitions.
No, 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 no. Based on the architecture that I'm going to present, I'm just coming to the architecture. As in all, total, we have total 10 threads. So based on the data size that is coming up, we are partitioning into those threads. Although this number of threads can be increased, there is no like a limitation as such. But yes, because
How many threads you used?
10, maximum 10.
or you use Sentry?
Yeah, these are not from not from the the libraries that are available for the programming languages. These are from the kernel levels using OpenMPI and MP.
Okay. Okay, then Prabhat, I had this queries only.
Yes, okay, sir.
Yeah. Thank you very much, Asin sir. So, if you all permit, then Prabhat can go for a submission of the thesis.
Yes, it seems he can go ahead, provided like this points are a bit carefully checked there, Prabhat.
Yes, okay, sir.
Okay, we'll take care of it.
Yes, sir.
Okay, thank you very much, Asin sir, and Shazul sir, and all the members here. So, for your valuable times and comments, that will obviously going to improvise our work. And with this, we are going to conclude the meeting. Once again, I would like to thank all of you for, from the very beginning, Asin sir is associated with our work. So, the sir is here. So, thank you very much.
Thank you. Thank you.
Yeah.
Thank you.
Okay, thank you.
Bye bye.